The Science Salon podcast. I'm your host, Michael Shermer. As you all know, we do this once a week on the Tuesdays that books are released. This week's book and author is my longtime friend, Christof Koch. His new book is The Feeling of Life Itself, Why Consciousness is Widespread but Can't Be Computed. So you can see where that's going. I've known Christof since the early 90s, so probably almost close to a quarter century now. He's one of the most interesting people I've ever met. Super delightful guy, very smart, very witty, and has a real lust for life. And he's now left Caltech and has been at the Allen Brain Institute for, must be at least a decade now. And so we talk a little bit about that, the research and work that they do there. What are they doing when they're trying to find the neural correlates of consciousness? We get into the hard problem of consciousness and what that means, the integrated information theory of consciousness versus the global workspace theory of consciousness. And we talk about comas and vegetative states, and is there anybody there? How do we know? How do you define these things? The nature of the self and identity. If you have a split brain, there's really two minds. So if you have two minds, is that two persons, two selves? What does that all mean? So we explore some of that, and pretty much cover most of the major philosophical issues related to the mind-body problem. How consciousness arrives from a physical system, why he thinks that no computer will ever be conscious, what they're designed to do, and the underlying architecture, the structure of computers, that as currently configured will never, ever be conscious. And he makes a pretty good argument, I think. Not that it can't be done, it's just that it's not going to be done the way we're doing it now. I think he's probably right in the sense that, it's a much harder problem than anybody ever realized when we're talking about creating conscious computers back in the 90s, and still hasn't happened. I think it's just way more difficult than anybody realized. And anyway, it's a great book. It's really, short, straight to the point. He's a clear writer, clear thinker. And again, it's in the title itself. What is consciousness? It's the feeling of life itself, or as he says, even more succinctly, it's experience. Consciousness is experience. So consciousness is lived reality. It is the feeling of life itself. It is the only bit of eternity to which I am entitled. Without experience, I would be a zombie, a nothing to myself. Anyway, great book. If you appreciate the podcast as usual, we appreciate your support, either through Patreon every month or at skeptic.com/donate. Thank you. I give you Christof Koch. Christof Koch, is that Francis Crick behind you there?
Yes, it's a painting he gave me. It's a photograph of him in his wicker chair. He gave that to me half a year before he passed away, and it says, "For Christof, Francis, keeping an eye on you."
So you have him there in your office, watching over you at all times.
Looking over my shoulder at all times, yes.
And that also looks like the other, is that the cover of the Beatles, Sgt. Pepper's?
Yeah, but it was one of the Tucson conferences.
Oh, I see. Very good, right.
It's modified to include David Chalmers, myself, and two other, couple of other scientists.
Oh, that's really funny. Yeah. Very good. So I am speaking to you at the Allen Brain Institute in Seattle, Washington, where you were wooed away from Caltech, amazingly enough.
That's correct.
So before we dive into your book, just again to introduce everybody, just remind you why you're here. Your new book is...
you have it. I haven't seen it.
You haven't even seen your book?
No.
Yeah, The Feeling of Life Itself, Why Consciousness is Widespread but Can't Be Computed. Okay, well... Yeah, some people are going to dispute that, but that's before we get into that, though, just kind of catch us up. You're famous for having worked with Francis Crick when you were at Caltech, and you had kind of the traditional academic career, just grinding along, doing your thing, and then all of a sudden you're now in Seattle running the Allen Brain Institute. What is it you're doing there, and why did you do that transition?
Well, so we have 330 scientists focused on a few very large projects in the brain sciences. So, for instance, we have a big Nature paper coming out next week where we look at human brain material, so either from dead brain or from neurosurgical excised brain tissue, And 20 minutes later, after the neurosurgeon takes it out of the brain of a patient, it sits in our lab. And then we can do what's called single cell transcriptomics. So we can read out all the genes that are expressed in the different neurons to get a view of how many types of different brain cells there are in a human compared to the different types of brain cells in a mouse.
How many are there in humans versus a mouse?
Well, in any one cortical area, it turns out it's roughly the same, roughly 100. And that's the same number in human and in mouse. And it's sort of similar, the number of genes. When people first in the late 80s identified 20,000 genes in the mouse genome, they said, well, humans are clearly vastly more complex, so they're going to have 100,000 or 200,000. No, they have roughly the same number of genes. We have roughly the same number of types of different neurons, probably across the entire brain on the order of 1,000, 2,000, 5,000. Although there are many, many differences, and those differences matter. So particular, if you, for example, if you are into making drugs to help people with schizophrenia or autism, and you, for example, you're after serotonin receptors, and you make a drug based on some animal that you, particularly on mouse experiment, well, the same serotonin receptor may be distributed. Looks like it's on different types of cells. So therefore, what you find in the mouse doesn't really generalize to what you find in human. So while the principles are similar, the details really differ greatly, which explains why so much drug research that was started in the mouse, you can cure mice, but you can't cure human with that.
And is that because just the combinatorial complexity of, when you just start grinding along on the numbers of combinations, and they just don't extrapolate from one species to the other?
Yeah, well, I mean, you got to remember, if you trace us back and down the evolutionary tree, the last common ancestor lived, at the time of the dinosaurs, 65 million years ago. And so since then, we've diverged. Yeah, our brains are built along similar principle, but all the details have changed over the last 65 million years. So you really got to work with human brain tissue, which of course is much more challenging.
What year did Francis die?
In 2004.
2004, so it's 15 years. What have we discovered since then that he would be surprised about or pleased to see solved or still mystified and he, or whatever?
Well, so first of all, I was recently rereading, there's one of his better known articles was written in 1979.
Oh, wow.
Okay, 1979. So that's basically, that's 40 years ago. When he just made the transition from molecular biology to neurobiology, and when he also made the transition from Cambridge, England, to La Jolla here in California. And he wrote a very forward-looking article about brain science and some of the things that should be invented. And so there, for example, he predicted, well, wouldn't it be great if we have tools that light up neurons with flashes of light when they discharge electrical activity? Wouldn't it be cool if we can turn neurons selectively on and off? These are all tools that people developed over the last decade. So those things he would have been comfortable with. What he probably would continue to be surprised at is the vast complexity of the brain. When he and I worked together 15 or 20 years ago, we thought there were going to be simpler molecular codes that express which cells are living in which specific part of the brain, and all of that turned out to be much, much more complicated than we had imagined. And some of the possibility to manipulate the human brain, again, he might have been surprised. On the other hand, he was very fast thinking, so I'm not sure whether he really would have been surprised by many of the current developments.
I was trying to find that famous quote from his book, The Astonishing Hypothesis. What is it? You, your joys and your sorrows, your memories and your ambitions, your sense of personal identity and free will. Let me see, what's the rest of that quote? It's still kind of true. Yeah. Are in fact no more than the behavior of a vast assembly of nerve cells and their associated molecules. Of course, that's so broad, it's kind of true by definition. But why was that astonishing at the time?
Well, it wasn't.
Yeah. It's kind of a book title.
It was a book title that he later on regretted. It was suggested to him by his publisher that would be catchy. No, this is what most brain scientists believed at the time and believe to do today, that ultimately who you are is a product of your neurons. Although, and this is important, it's not the same as your neurons, right? So my experience, my love that I have for my wife or for my children, it's not the same as the neurons that are involved in that action. Those are really two different things. One is necessary for the other, right? It's sort of the physical substrate of the other. It's not my heart, as ancient believed. It's not my liver that gives rise to my feelings. It is the brain. But the brain is different from the feelings that the brain gives rise to.
Yeah, so there you're identifying the hard problem of consciousness, what it feels like to be something or to experience something.
Yeah, I mean, yes, you're right. So the hard problem is trying to understand how one relates to the other in a scientific, empirical, reducible manner. And of course, some philosophers claim this can never be done. Me, I don't know. Philosophers have claimed many things throughout the ages that can't be done. So one has to be a little bit skeptical. It is indeed challenging. It is difficult. There's no question about it.
Yeah. So, but the question is it a conceptual problem that is a problem with our concepts, or is it a scientific problem? That is there any experiment you can run and say, that explains exactly why I experience something?
Well, so we need an entire theory. There's no single experiment that will ever convince anybody. But it's the same in physics. If you look at quantum mechanics, as you well know, Michael, quantum mechanics makes some very weird predictions, right? Mm-hmm. And so, but collectively, scientists believe quantum mechanics is the best description we have of the universe at the micro scale. And so ultimately, we need a theory of consciousness that explains your consciousness and how it arises in your brain and what happens when you might get a stroke and what happens in babies, what happens in animals, what happens when you go to sleep, what happens when you have, various mental diseases. And then we have to see what are some of the implications of such a theory, for instance, for computers or for other systems that we might not conventionally think of as being conscious.
Well, so the title of your book, The Feeling of Life Itself, that is your definition of consciousness.
Ultimately, yeah, it's a quite common one. Ultimately, consciousness is any experience, any feeling you have.
Yeah, you say consciousness is experience.
Yes.
As in equals.
Yes, yes. It's any experience that you have. The subjective aspect, it feels like something, to be angry, to be upset, to know that you're going to die one day, to be happy, to be in love, to have a toothache, to look at you, to hear me. Those are all different experiences. That's what consciousness is.
Yeah. So, but let's say you and I are both looking at a red dot or whatever, and back on our visual cortex at the same spot is lighting up in an fMRI. We would say that's the neural correlates of that conscious experience of seeing something red. But where's the red? Our mutual friend Deepak Chopra would say, where's the red?
Well, the red, in this case, the experience is a consequence of it's not a consequence. No, it's really you have a physical substrate. Let's see some neurons being, interconnected in a particular way, and they are associated with this feeling. It's not that first there is the physical action and then there is a feeling, because that's sort of dualism, and scientists, sort of tend to reject that. No, you have the physical constituency, you have your brain or parts of it, and then that sort of is coextensive with a particular experience, whatever the experience of being, seeing red or being angry.
Right. It seems to me this gets us to an answer to the question of the problem of other minds, or how do I know you're not a zombie and I'm the only human that's actually sentient, because your brain is wired the same as mine, or very similar, that the Copernican principle says I'm not special. So the chances that, you're completely different on an experiential level than I am, even though we have the same wiring, is very low. Therefore, the inference to the best explanation is we're all sentient.
Perfect. That's exactly, I couldn't have put it better myself. Now, I don't really know that, but it's an inference, as you said. It's an inference to the best explanation, yes.
Right. So, so that gets to, anyway, just sort of we're getting slightly ahead of ourselves, but you write here, consciousness is lived reality. It is the feeling of life itself. It is the only bit of eternity to which I am entitled. Without experience, I would be a zombie, a nothing to myself. So there is all the neural activity. Then there's this other layer of, I don't know what you want to call it, of sort of a metaphysical layer or a
No, it's not metaphysical. It's more real than.
Yeah.
That's my reality. Remember, the only thing I know of is that I have feelings. There isn't anything else.
Right. But by this definition, then I would assume my dog, you have a dog, I have a chocolate lab. I assume he experiences things. He has experiences similar to mine. Therefore, yes. He is conscious.
Yes, there's no question about it. Yeah. I don't know, by the way, a single dog owner or cat owner that would deny that their companion animals also have feelings. Now, they're not as complex as yours or mine. For example, my dog doesn't know he's going to die one day. Right? Dogs don't have that capacity. I'm not sure how much my dog, thinks about himself. I, like you, think about myself and I project myself in the future. I think about the past. My dog lives, is much more like a Buddhist. He lives in the here and now.
Yeah.
He's very mindful in that way, in a way most of us are not. But yes, he has conscious experience, no question about it.
Your dog is enlightened.
In some sense, yes, he's more enlightened because I'm always obsessed about the future or about the past. Most people are, right?
Right.
You constantly think, well, what would happen? And then you replay the last dialogue, the last fight you had with your girlfriend or whatever. My dog doesn't do that. My dog is much more in the present.
Yeah. Yeah. But so by this definition, then it's really just a scalable spectrum of like instead of the lights coming on and off like a switch of consciousness, it's more like a rheostat that, you just kind of turn it up. It's very dim or it's a little brighter and brighter and brighter based on what? Not just the number of neurons, but how they're wired and the complexity of the neural networks and so on.
Again, you're putting it very well. Now, that's probably true both at the level of individual over your lifetime as well as across species. So in other words, when you think back, when were you first conscious? When did you actually first have an experience? Was it, when your mom and your dad got together and the sperm fertilized the egg? Was it at the stage of blastocyte when you were 16 cells? Was it at the end of your first term when you had a brain? After 10 weeks, you have already a brain, right? And then that grows. Is it when you exit from your mom's womb into the world, when you finally have to breathe oxygen and you scream and there's light and sound and all of that? Or does it occur during, in the first 2-3 years of life when you start speaking? And even as a teenager, there are certain things that you still have no experiences of, like the experience of being in love, of sex, of wine, of drugs, all of those, right? So you expand your conscious experiences. And then, of course, at the end of life, maybe there's dementia, maybe, you have a stroke or something, so it waxes and wanes as it does during the day, right? When you go to sleep, your consciousness is off. And the same thing, as you said, will change across different species, somehow scaling with the complexity of their brain.
Do you distinguish between consciousness and sentience?
No, I don't. Awareness, consciousness, subjectivity, those are just different names, but it's all the basic same phenomena. It feels like something.
Right. You experience pleasures, pains, suffering, whatever.
Yes.
Yeah, that's why I always liked Jeremy Bentham's famous quote about it, sort of the grounding of animal rights. It's not can they think and can they talk, but can they suffer?
Yes. Ultimately, I think that's a key insight, the suffering, the ability to suffer or not.
I mean, we're way ahead. I mean, this is the end of your book on animal rights, but that's kind of where it begins. And if you really believe that, then I don't know how many sentient beings we kill every year. It's like 1 trillion a year if you count every chicken and fish and so on. I mean, this is like worse than the Holocaust every year.
So I saw recently a quote in a restaurant in Germany, and they said for animals it's Treblinka every day.
Mm-hmm.
Yeah. So I mean, the main reason I'm a vegetarian since many years, because I don't want to do that anymore. Certainly advanced. So I had this epiphany the night my beloved German Shepherd died. Was 15 years ago. The black German Shepherd, Nosy. She died in my arms. I was distraught and was crying. And then I thought, well, at the same time, I love the flesh of pigs and lambs, and their brain is roughly the same complexity as that of my dog.
Right.
That night, I promised my nosy, in her honor, I would never eat the flesh of another conscious creature again.
And you did it.
And I haven't.
What was her name?
Nosy.
Nosy.
Nosy. She was intensely curious. Nosy, my black German Shepherd.
Oh, I see. Nosy. Yes. Okay,
Yes.
got it. Black German Shepherd. Yeah, German Shepherds they're really great dogs. I've had two of those. Yeah. Well, I mean, this is one of those things you think. Like I wrote that book, The Moral Arc, and people then
Yes.
would ask, well, what's the next stage? Well, it's got to be animal rights. And it's one of these things. Like if we were chronically frozen and came back 500 years from now, how would people then look back at 20th century, 21st century? What we think about now? They would probably accuse us of being, like the equivalent of slave owners or genocidal, maniacs.
I think those are excellent point. I mean, today, of course, we believe we are morally superior to every other previous culture because, we have less racism, we have less misogyny. But you're right. There are horrible other things that people simply don't think about it. When you talk to them about suffering, some people will say, yeah, you're probably right, but it tastes too good. Most people don't even think about it at all.
Yeah.
Just like presumably, when the Greeks were around, nobody really thought much about slaves. I mean, Aristotle and Plato and Socrates, for sure, they didn't write really about it. They didn't even consider it a real issue.
Right. Not even noticeable.
No.
Yeah, Dawkins wrote an essay, it was republished in his book, The Soul of Science, I think, about wanting to be a vegetarian. And he kind of went through Peter Singer's famous arguments about the expanding moral circle and all that. And basically at the end, he says, I know he's right, and I know I shouldn't do it, but I go to a restaurant and I can't help myself. It could be we need, everyone needs to change. You need more than the arguments. You need some kind of cultural momentum.
Yes, and I understand. I mean, that's why I took in my case, the death of my beloved pet, because, the taste of meat is deeply ingrained in our culture. Yeah, so it's just like with many of the other isms, we need to change our entire culture. Why bring up children with all this flesh, right?
Here's your current dog.
From
your perspective, did you draw that?
No, I had an artist.
Yeah.
Exactly. Ruby, Bernie's mountain dog.
What's her name?
Ruby.
Oh, Ruby.
Like the jewel.
Yeah. Right. Anyway, well, I mean that's it's one of those issues that I think culturally we'll get there. I think it's going to take longer simply because we all have to eat, and meat is such a big factor. It was easier, I think, to give up slaves because not that many people actually own slaves. Everybody eats, and everybody eats every day, and most people eat meat. I think it's just a harder moral revolution to bring about.
I agree, but there's some promising development, right? There's Impossible Burger, Impossible Food, there's Beyond Meat. It's getting more expensive, and with 8 billion people, it's not clear whether in 50 years from now we can still support this mass agriculture given, the associated environmental costs. So maybe things will change.
I've been having the Impossible Burger at the local Islands chain here in Santa Barbara. It's pretty good. I mean, it's a little expensive. I think it's $15 or something like that, but the cost will come down in time.
The cost will come down, and apparently the Impossible Burger, they offer it now at
Burger King.
Burger King.
I think it's the Impossible.
People can't distinguish it.
I think they're calling it the Impossible Whopper.
Yes, exactly. Impossible Whopper. And people can't tell it apart from the real one. So that's encouraging.
Yeah. All right. So this is your previous book was about a romantic. What did you call yourself? A romantic
consciousness. Confession of a romantic reductionist.
Romantic reductionist. Yeah. You've always kind of flirted around with not being strictly reductionistic.
Well, yes, so that's entirely true. Very good. And of course, in consciousness, you have to take a holistic perspective because consciousness ultimately is about a whole, W-O-A-L-E, the whole.
Yeah.
And because my conscious experience is holistic. It's one. It's not many. I don't experience many things at any given point in time. And so therefore, you have to ask, what is a whole in your brain or anywhere else, and each hole constitutes a conscious being, a conscious thing, a conscious entity that has some experiences.
Yeah. In the book, you go through these surgeries where they take out different parts of the brain and consciousness is still retained. Walk us through some of that research on the search for where it's located and why it's impossible to find it in any one place.
Well, so we do know enough from clinical neuroscience the last 150 years to know there isn't any one place where sort of it all comes together. All my conscious experience of me are not in any one place. There are, of course, places in the brain where if you have a stroke, you become unconscious, so particularly in the brainstem, right? So your brainstem is like this pipe, roughly 1 inch thick, 2 inch across here, that connects the spinal cord with my brain proper. If you have a lesion there, you're typically in bad shape, right? You may be in coma or in a persistent vegetative state. But those are just the enabling factors, just like you need your heart to beat. If your heart doesn't beat within 7 to 10 seconds, you faint. So that's one of the necessary background conditions. Same thing, your brainstem needs to, all those neurons in there need to be active in order to for your cortex. It's really cortex, the outermost shell, at least in us humans and in other mammals, that gives rise to any one conscious sensation. And there we know from people like Oliver Sacks, the neurologist, that specific part of this cortical sheet, it's really like a pizza. In us, it's like a pizza. It's a 14-inch diameter, 2 to 3 millimeter thick, and you've got two of them, and they're highly convolved and put into your skull. And different parts of that mediate different aspects of feeling of self, feeling of seeing motion, seeing of color, of hearing. And we know this from people who have strokes or lesions. They miss entire categories of experience. They don't see color anymore. They feel everybody else has been replaced. They lost the feeling of familiarity. And so through clinical natural experiments like that, we know there are specific parts of cortex that are really essential for different classes of conscious experiences.
Yeah, I always liked about Oliver's books is, basically each chapter is something that's gone wrong in somebody's brain, and then what that looks like in terms of symptoms and experiences and behaviors.
And what it actually feels like. He's really very good at conveying, how does the world, how does your experience of the world change if you have these specific brain lesion, or you're unable to remember, or you always live in the present. And that teaches us a lot about consciousness. There's another class of surgeries. So medical sciences in general and surgeries probably taught us more about consciousness than most other fields. Mm-hmm. So a series of experiments that I know you know well that were done at Caltech by, remember, Joe Bogan, the neurosurgeon, and Michael Gazzaniga and Roger Sperry, who got a Nobel Prize for it, were these split brain experiments. Yep. So what happens in a split brain experiment, of course, you have a person with epileptic seizure. The seizure might start in one cortical hemisphere. So seizure is just a hyper excitable, aberrant electrical activity that can, if it spreads, can engulf the entire brain. And then you get these grand mal, these attacks. So to prevent it from spreading, a radical therapy is to cut the wires. There are if you look down at the brain, right, it's like a walnut. There are two halves, and the two halves are connected by 200 million fibers called the corpus callosum. And if you cut that, then you can, yes, beautiful, yep. Exactly. And if you cut that, you can prevent the seizures from spreading. But then it turns out now you have two minds. In at least some of these patients, you have two minds inside one skull. You have the left brain that gives rise to a mind, and that's the one that speaks. That was the great discovery, that the speaking parts is really specialized. In most of us, it's the left hemisphere, Broca's area and Wernicke's area. Mm. But you can shut that off, for example, by anesthetizing it, by injecting sodium amytal. And then there's the other mind in the right hemisphere, and they don't know about each other. It's like being on the dark side of the moon. There's someone in my head, but it's not me. Like the Pink Floyd song, quite literally, because each one is its own experience. Each one believes itself to be the only thing inside that body. But then, of course, the patient, you can ask the patient, and sometimes the patient complains the patient, she or he will say, oh, my other hands always does things that I don't want it to do.
Right. Yeah.
Because it's the other consciousness that have also a will of its own, and then they have to duke it out.
Yeah, it's the problem of identity and self. Is there a single self if you can so easily divide a brain into two minds?
Well, I mean, so easily. I mean, it is massive brain surgery.
Yeah.
And in most of, it's a pretty rare surgery. It's not done that even. Yeah, but if you physically cut the brain into two, yes, then there will be, at least this way, not this way. But if you cut it this way, there will be two. Now, you can do the opposite also. So this is what I talk about. So I can take your brain and my brain, and I can do sort of the very opposite of split brain. So I can start putting in wires between, let's say, my visual cortex and your visual cortex. Okay, so let's say I have some future, Neuralink, Elon Musk-like technology that allows my visual cortex to talk to your visual cortex. So at first, what the theory that I discussed predicts, at first I see normally like I see now, but I also see a little bit through your eyes. So what you see is like a ghostly image, like, augmented reality superimposed onto what I see. But I'm still me and you're still Michael. Now, what the theory predicts, this integrated information theory predicts, that as I increase the bandwidth of this connection, as I add more and more fibers to this artificial brain bridge between your brain and my brain, at some point, and it's very precisely defined when, at some point abruptly, I will die, I will disappear. Christof will be no more. Michael Shermer will disappear. Instead, there will be this new thing, this Übermind, this new conscious mind that has footprints that lives in two brains, in your brain and in my brain. It has four cortical hemispheres. It sees through four eyes. It hears through four ears, and it talks through two mouths.
So it'd be a different world. It'd be a completely different experience.
It still has it still has access to your memories. This mind still has access to my memories. Of course, it will have aspects of your personality and my personality. There could be big fights going on, but it will be a single mind, just like the Borg. There will be a single mind, call it Michael Christof, some amalgamation of your mind and my mind. There's always only a single consciousness. And then as I progressively reduce this bandwidth, these wires between my and your brain, at some point abruptly, you will find yourself back in your brain, and I will find myself back in my brain.
So since I showed this picture of your dog Ruby through your eyes, sort of looking down, you can see your legs, and there's Ruby for those who are just listening to this podcast. If you had a brain link between your visual cortex and your dog's visual cortex, if you cranked up the electricity enough, would she suddenly see that? Almost like looking in a mirror, like, there I am.
It would. Well, if it's a single mind, it would be a sort of a weird canine human mind. We would be fused. Yes, it's
That's really weird. That is really spooky.
I mean, it's easier to think about it, So, for example, when you're making love, you must have realized this, so you're making love, you're sort of, your bodies are interpenetrated, but you realize that she is, assuming you're making love to a woman, that she is still her own mind and you're still your mind, and you can look at each other, but you can never bridge that gap, right? Mind the gap. There's always this gap. Now, with brain bridging, the theory says if I directly connect my brain with her brain, then at some point there will only be a single mind. We will truly be merged like lovers. There will only be one mind, like Tristan and Isolde, in Wagner's eponymous opera. There will be one mind. There will be no more and. There will only be Tristan Isolde.
That I think it was a New Yorker cartoon of two behaviorists after making love. The one says, you had a really great time. How was it for me?
Yeah, this is the very opposite.
Yeah.
Now, interesting, this might happen already on this planet. There are twins. I'm thinking right now of identical Siamese twins in Canada, here in north of us, here in British Columbia. And they were born with what's called a brain bridge, a thalamic brain bridge. So due to some birth defect, their brains never really truly separated into two brains. And there's so the New York Times, wrote a long article about it. And there's some evidence that one of the girls can look there, the other girl can look over there and can partly see through the eyes of her of her Siamese twin, partly because of this bridge.
So for the one looking, that's just such a weird idea. So they're really getting different inputs and combining them into some kind of field. I'm envisioning some kind of a split field, but a bird that has two eyes on either side of its head.
I think of it like augmented reality at that point, right? The point about augmented reality, for where this goes, I see still the real reality, but then I have these virtual images that are superimposed. Except here they're not virtual; they're real. But at some point, if there's only one mind, then this is your experience of the world. You see the world through four eyes. I mean, in principle, yes, we are, of course, only used to seeing the world through two eyes, but in principle, you can imagine now I see the world through four eyes. A single conscious view, a single mind.
Maybe so the augmented reality may solve the problem, Thomas Nagel's, what it's like to be a bat. We can just actually put the goggles on and give the equivalent of sonar.
Because you're now not a bat. You're a bat, you're a bat human, which is different from a pure bat.
That's true, right.
So in that sense, I will never know really what just a bat is by itself, because my brain is different. And so my brain cannot be, the brain of a bat.
The most of that would happen, you'd just be a bat wondering what it's like to be a human. Or something like that. I haven't had a lot of experience with virtual reality, but I was at a conference recently where the virtual reality goggles helmet thing was a image from a 110-story building in LA or wherever it was, looking down on a plank sticking out of the window, and you walk out on the plank. So just standing there watching the guy, they were if you can last the whole 2 minutes or whatever it was, and you can walk all the way out to the end, you get some little present or whatever they were giving away. And to me, it looked ridiculous. Of course I could do this. Anybody could do it, because the plank is actually sitting on the floor 1 inch above the carpeting. But the moment I put it on, it's like, I can't do it. I am not going to be able to make it out there. Even closing my eyes, I would just kind of open them a little bit and peek, and, I'm looking 110 stories down. It's like, I can't do it.
What it shows us, it's really interesting. It shows us that visual, in our case, because we are visual creatures, visual input can override our prefrontal cortex knowledge. As you said, perfectly well there's no danger there, but the visual input, sometimes it's even more powerful when it's combined. Did they have like sounds of wind?
No, there was no sound. It was just the visual. Okay. Yeah.
The visual input by itself is so powerful, it can override your knowledge. It's like visual illusions, right? I mean, this again. There are all these powerful visual illusions. You perfectly well know you're being fooled, but you cannot not see the illusion.
My favorite is Jerry Andrus's The Impossible Crate Illusion, where
exactly.
he had the actual crate built.
Yes,
it's even more.
You perfectly well know that it can't look like that, but your brain fools you because that knowledge isn't sufficient to break the individual percept.
Yeah. So the Musk Mindlink or whatever this thing is going to do. I haven't really followed it that closely, but the moment they say, we're just going to open up your brain and stick this thing in there, it's like, wait, time out. That's fairly risky surgery to do that, right? Just, open up the skull cap and put something in there and then put it back on. That's not a trivial thing to do.
Correct. And so right now and for the foreseeable next decade or 2 or 3, that risk profile is only worth it if you have, if you're paralyzed or,
Parkinson's disease or something.
Or Parkinson's disease, or, if you're significantly impaired. All this augmentation right now is just simply too risky. And no surgeon at least in the West would do that because it's simply too risky. There's always a chance of bleeding. There's always a chance of infection, etc. And so you only do that if there are strong reasons to justify those risks.
Yeah. So, if you had contact lenses that had access to the internet or glasses or something like that, that seems fairly easy to do. A cochlear implant, that seems far less invasive than what Musk is proposing.
Yes, but people have done this now. Brain-machine interfaces, and in fact, that's also what Neuralink wants to do for quadriplegic. So these are people, who have a high up lesion in their spinal cord, who are, who can move any of their limbs. And so in that case, the risk is worth it in order for you to control a wheelchair or to control your phone.
Right. So that's such a great example of Arthur C. Clarke's third law. Any sufficiently advanced technology
Can't be
indistinguishable from magic. So all you see is this guy is sitting there, and then things start moving as he's thinking about them. Well, that looks like telekinesis, unless you know the brain chip that's in there. How far has that come along since?
It's still so. If you look at, there are a few cases of these patients online. But then it takes a team of 3, 4, 5, 6 engineers and 3 PhD students and a lot of support. And you have to go in the clinic, and it takes you sort of 5 minutes to take a single sip from a straw. So it's still very much in its infancy. But it's like any other medical technology, right? Early on, all of these things like contact lenses are incredibly primitive, and then as technology gets relentless better, these things will be easier to use. But as you pointed out, anytime you go invasive, you go inside the body, the risk, increases dramatically, and so that'll slow down any technology. So adoption for most of us who have not, for actually augmentation versus just replacing a lost function, is still a ways away.
Yeah. Yeah. Now, when I read that, I remembered my mom had meningioma brain tumors. And, at the moment they did brain surgery, I think she had to take like anti-stroke medications and other medications for the rest of her life.
Yes.
Just by opening up the skull. Well, she did. She had 5 craniometries. These tumors kept growing back, and then 5 radiation treatments when they wouldn't operate on the brain anymore. And she ultimately died of this. But she was in a coma. Eventually she fell and hit her head when she wasn't functioning too well, and was in a coma. But so I was, reading your whole section here on people in comas or vegetative states and so on. And same kind of thing so many people experience. I would hold her hand and say, squeeze my hand, and then she would do it pretty much every time. So what can we conclude from that? I mean, the lights are on a little bit, the dimmer has come up just a little bit if she's responding in some way, or is that just more like a knee-jerk reflex with a verbal command?
Ultimately, it's difficult to know, but generally the assumption is if it's, if you hear me squeeze my hand, or you can also ask a more objective knowledge, were you born in Kansas City or not? So people do those sorts of, trying to communicate where what the answer is, and you see, is it just a reflex? Every time the brain hears a command, it just squeezes, or is it much more sophisticated? More challenging are cases, what's called minimal conscious MCS state or vegetative state, where you don't even get that, where no matter what you ask, or you ask them to move their eyes, there's no response. Yeah. And there are a few thousand of those patients, and you simply don't know whether there's anybody home. And then you need this technology that I describe in this book, this so-called zap and zip, where you stimulate the brain. It's a little bit like you take a bell and you hit it with a hammer, and you're looking at the reverberation. And based on the complexity of those reverberation that you pick up using EEG, you can ascertain whether the brain is still conscious, or whether it's truly in an unconscious state, like in a deep anesthesia or in a vegetative state when truly no one is home anymore. You still have the shell of the body. Like, do you remember Terri Schiavo?
Yeah, she didn't even have a brain. Wasn't it just mush or just mostly spinal fluid?
No. She had a brain. So she had an anoxia for 25 minutes before she was revived and put on a ventilator. At postmortem, it turned out the brain had shrunk by a great deal, by more than half, 50%. But she did have a brain. And of course, like many of these patients, in a vegetative state, she has occasionally these responses, where she would move. The eyes occasionally would move. Occasionally she would grimace. It's very difficult to say, is she laughing or crying or what? Yeah. So she clearly had some reflexes. So there's a difference between brain dead, when you have no reflexes whatsoever, and vegetative state patients, when they will open their eyes, occasionally they will move. Brain dead patient doesn't have any of that.
Right. So what can you assume in terms of personhood or sentience?
Brain dead, as far as we can tell, if your brain is dead, you're dead.
Yeah.
Your body may still be alive, although that's disputed. But if your brain is dead, there's no one home anymore. And if so the modern definition of death, it used to be death is sensation of breathing, sensation of pulse, right? But now we know that's I can animate you, right? People invented in the 1950s ventilators, so now I can keep your body alive almost indefinitely. So now we define death, either cardiopulmonary death or brain death. If your brain is irreversible, broken, then you're not home anymore.
Yeah.
Although to your loved one, you might still look alive. You have skin pallor, your body is warm, your chest goes in and out, but that's because you're on a ventilator.
Right. Well, but I'm thinking of that in between state, the coma state, the squeeze my hand and they do or whatever. What is?
Well, if they do, then they're there. How much are they there? Are they just vaguely there, right? Are they just sort of in a sleep most of the time, and occasionally they wake up for an hour or two? Very difficult to tell. And with technology, it's interesting. Again, 50 years ago, those people all would have died very quickly. But with modern, 9/11, emergency rescue, helicopters, modern trauma surgery, we can pull some of them back. And most of them, we can return to normal life. But then there's this subset of patients who are so gravely injured, they're not dead, but they're not fully alive. They're sort of, hovering in this unfortunate state. And of course, with modern technology, you can keep their body alive for a decade.
Was it the Terri Schiavo case where the husband wanted to pull the plug and the parents didn't? Or is that
correct? Correct. It was litigated all the way up to the Supreme Court.
I remember Congress met on the weekend and the Supreme Court met.
George Bush got involved.
Yeah.
George W. Bush. But and that's not exception. As I said, there are thousands of cases like that, mainly in resting homes, hospices, etc. And it's a great it's a great tragedy for everyone.
Yeah. Yeah. Right. And then general anesthesia. Where does your consciousness or your sentience go?
Well, it's the same place where it goes when in deep sleep. It's gone.
It's gone.
It's simply, it's not there anymore because your brain is now in a different state. You're simply not conscious. That's what defines states of unconsciousness.
Yeah. Yeah.
And then when the magic of it, you wake up, I can ask you, Michael, and then you come through and suddenly
it comes all back. There again. The lights come back on.
The lights come back on again.
Yeah.
The wonder of it all. Yes.
Yeah. All right. So walk us through this, this latest theory of neural correlates of consciousness and the information processing and all that.
Well, I mean, there are really two sort of popular scientific theories of consciousness around. One is the global neuronal workspace theory that essentially says it's a functionalist account that essentially says consciousness is the performance of certain function involving short-term memory, involving planning, involving self-monitoring, and those things are implemented in particular parts of the brain. And also, once you replicate those functions on a machine, including monitoring self, having planning, having ability to speak, etc., then you will get a conscious machine. The other popular theory is called integrated information theory. It's by this psychiatrist and neuroscientist Giulio Tononi, and I'm a big fan. I've worked with him for many years. That says no, consciousness is more fundamental. Consciousness is different from its material underpinning. It's a distinct different thing. In fact, it's the only thing that I've directly acquaintance with, and really has to do ultimately with the complexity of any physical system. Ultimately, it has to do with the ability of any physical system to causally influence itself. Ultimately, it's about intrinsic causal powers. It's something Aristotle said 2,300 years ago. You exist, you're conscious to the extent that your brain, the thing that is conscious, has causal power upon itself. That means it can be influenced by its previous state, and it can determine its future state.
So self-referential.
In some sense. Causal power. Ultimately, how do I know anything exists? It really goes back to fundamental ontological consideration. How do I know anything exists? Mm-hmm. I only know things exist by the influence they have on me. So gravity, I know it exists because there's tides. There's a famous apple, of Isaac Newton. That's how that's how we know ultimately gravity exists. Now, this theory applies causation to itself. You exist as a thing, as a conscious thing, to the extent that you have causal power upon your own system. And the more causal power you have, the more complex the system is. The more you exist, the more you're conscious. And there are certain consequences that you can test in different brains.
Yeah, Dan Dennett uses something like that in his book Freedom Evolves, where he argues for something like free will or volition as a function of the complexity of the organism to do what you're describing. So the more of that you have, the freer you are. Or he doesn't say that. He said the more degrees of freedom you have to make choices within your environment to move around and affect things. And in the case of humans, we can self-reflect on that and know that these are the things that cause me to do certain things. So I'm going to change my behavior to redirect that causal vector to do something else that I know it will have that effect, and so on in a self-referential way.
That's correct. But of course, Dan Dennett also fundamentally believes that there isn't anything like consciousness itself. That's really a big illusion in his eyes. We're really confused about it. Ultimately, consciousness is just a set of behavioral dispositions. Ultimately, consciousness is a function I carry out, a whole set of functions I carry out. And once again, once you implement those functions in a different system, like a computer, that system will be conscious. So in that sense, this runs radical contrary to his notion, or the general notion that's such a myth in Anglo-American university departments and in big tech, that ultimately machines will be conscious because, hey, once they can do everything we can do, then of course they're going to be conscious. And I think things couldn't be more wrong.
Well, then how would you ever know the machine was conscious?
Well, okay. So let's take this apart. It is true if you think about intelligence. Intelligence ultimately is about behavior. It's about function, and there's no question. At least in principle, machines can do anything we can do, including being creative and speaking and talking and all those other things we associate.
They're going to be able to write novels pretty soon.
At some point, yeah, you can go to OpenAI and you can use their GPT algorithm, and it generates pretty cool, text, prose. But but those are all about functions.
Yeah.
So intelligence ultimately is about behavior. It's about function. Consciousness is not about function. It's not it doesn't relate to function. It's ultimately being. It's ultimately a state of being. And yes, in evolved creatures, function and intelligence and consciousness usually evolve together, but you can certainly artificially separate them. And so you can build a machine like DeepMind or Alexa, 20.0 in 50 years from now, that's incredible smarter than you and I, but it won't feel like anything to be this machine, which is very different from consciousness, which is ultimately about being.
Yeah, my favorite example of this is meeting David Ferrucci, the designer of Watson, the computer program that won Jeopardy.
Yes.
So I asked him, does Watson know that he won Jeopardy? I mean, was he just totally excited that he beat Ken Jennings and Brad Rutter and he's the world champ? No, of course he doesn't even know that he's playing Jeopardy. Doesn't even know what Jeopardy is. It's just an algorithm grinding through Wikipedia pages to find the best inference to the likeliest answer and so forth.
Yeah, but most people, Michael, don't have that intuition. Most people say, well, I mean, Dan Dennett would certainly say, well, not Watson maybe, but if you make Watson, sophisticated enough, it does all these computation. Yeah, of course it's conscious, because what else is consciousness than carrying out a bunch of functions? So that's what I mean by my subtitle of my book, consciousness can't be computed. It's not just a simple computation. So even if you made a supercomputer simulation of a human being, including all of its neurons, that's just a computer program. That doesn't mean it's conscious. Just like a weather simulation doesn't make it wet, right? If you simulate a rainstorm, it's not wet inside the computer.
Yeah.
Because those are different things.
But we are machines. I mean, we're made of molecules, atoms and molecules. That's a machine.
That's correct. So in principle, you're entirely correct. So my brain, as I say, is a piece of furniture like any other furniture. Okay, it is true. It is by far the most complex piece of active matter in the known universe. And so ultimately, that if I want to build a conscious machine, I have to build it in the image of man. So you do what's called neuromorphic engineering. You build, and IBM has a project like that. You're actually trying to build neural hardware, neurons that have this massive overlap in the input, in the output, that don't talk just to 3 or 4 transistors, but talk to 10,000 transistors. Yes. So in principle, you can get a machine that has human level consciousness, but not digital programmable machines right now, because their architecture at the level of the metal, of the actual wires, at the actual gates, is vastly simpler than our brain.
Yeah, but if so we just apply Moore's law out for, I don't know, another century or two, and eventually we get human level complexity. It still can't happen.
No, so yes, you'll get human level intelligence. I'm not disputing that. But ultimately, look, conscience, ultimately it's a physical thing. It has to do with the complexity of the ultimate hardware, not with the behavior. So you have to ask, if you actually look at a CPU, you look at its wiring, you have one transistor gate that's typically hooked up to 3 or 4 other transistors with very little overlap. My brain is radically different. My brain has one neuron that's connected with 50,000 other neurons. The neighboring neuron may share 40,000 of those inputs and outputs. The neighboring one may share 39,000. It's a radical different architecture. This architecture, our evolved architecture, really gives rise to high level of intrinsic causal powers, which per the theory is what consciousness is, which is very different from simulating it in a digital program on a vastly simpler machine, no matter how big this machine is.
So then again, if we're a machine, then how is it that it happened with us, but it can't happen in a computer?
It cannot. It could happen in a computer if you build it in the right way.
Oh, I see. All right.
Because the way we build our machines is not to give rise to consciousness. Is to do simple things over and over and over and over again, right?
Right.
For doing your tax return or doing all these other things. That's what machines excel at, and they'll get better at it, and ultimately they may be smarter than us. But that's very different from actually having an experience. Look, there's a great metaphor or a great analogy. So I have a friend, she's an astrophysicist. She writes down the equation of general relativity to simulate the black hole at the center of the galaxy. Okay, you know, there's a black hole at the center of our galaxy. It's roughly 1 million solar masses. But funny, she is not concerned that she's going to be sucked into the black hole
when she writes out the equation.
Now, why is that? It's a perfectly good, it's the best simulation in principle of the power of gravity. Yet, where's the difference? Why doesn't she get sucked into it? Because it doesn't have the causal power of gravity. Just because you simulate the equations of general relativity does not mean that you get the causal power that goes hand in hand with bending space-time, as that mass does. Same thing with consciousness. Just because you simulate some of the behavior associated with consciousness does not mean you get the same causal power that consciousness has.
I gotcha. Okay. So you're a Star Trek fan. Data could never be a person in the sentient way that we are.
Well, no, I don't know what his hardware is. Just like Eva
right.
and Ex Machina, right? It's suggested there's some sort of neuromorphic brain. It's never really explained.
Yeah.
Look, if it's similar to the architecture of our brain, yes, it could be conscious. It could even be more conscious than I am.
Okay, so it has to do with the purpose of the design. What are you designing it to do?
No, not the purpose. It has to do with the actual. You have to look inside the box, actually look at the hardware, the stuff that actually does these transformation. And you have to ask, how complex is that? Using this specific measure called phi, you can actually compute for any particular for any physical system, you can actually compute how much phi it has. In principle, it's totally computable. It's not some airy-fairy mysterious stuff. Ultimately, it's causal power. It's the only thing that exists.
Yeah, so tell us what phi is again.
So phi is
PHI.
Yeah, PHI, the Greek letter. It's a measure of it's a single number between 0 and any positive number. If it's 0, the system doesn't exist for itself, is not conscious, has no causal power upon itself. The larger this number is, the theory said it's really a quantity of consciousness, if you want. It doesn't describe the qualia. It doesn't describe whether it's a smell or, the feeling of life itself or the seeing red. So for that, you need different measures. But phi itself just characterizes the irreducibility of the system, how much a system exists for itself. Ultimately, it's sort of the quantity of consciousness of that particular system.
Yeah. So in my last book, Heavens on Earth, I have a chapter devoted to the people trying to upload the mind, the singularitarians, and all that.
Read it.
So I met this group that are trying to not copy the connectome in a scanning kind of way. They want to actually they sacrifice like a sheep brain, froze it, and then sliced it up. And then scanned, scanning electron microscope of each of these slices with the idea at some point you'd have a digital file that represents every.
This is a group in Cambridge, right?
Yeah. Yeah. There's a couple of groups. There was one that was doing this at a lab in Fontana, California, 21st century medicine. Their main job is organ preservation, organ transplants, and so on. But then they also have this little subdivision. I'm not sure they're still doing this, but where they would freeze a brain, sacrifice the animal, and then infuse it with a preservation, antifreeze, so the water freezing doesn't shatter the neurons, and then unfreeze it and slice it up, and then you can see that the synaptic connections are still viable. So this was for them a proof of concept that you could be, if you could do it properly with cryonics, although they still have a ways to go on this, in principle, the memory self, so they're defining the self as your memories. I have a problem with that because I think we're more than our memories. We're also our point of view self, through the eyes self from one moment to the next, and copying the connectome and then turning it on somewhere else or putting it in a digital file into the cloud. That's not going to be you. It's not your point of view looking through your eyes self.
It's not your consciousness, Michael.
That's right. It's not your consciousness.
So leaving aside all technological problems. So we're actually doing this. We have a project here at the Allen Institute funded by the IARPA, where for the first time we cut up at electron microscopic level with 3.5 nanometer resolution a complete cubic millimeter of a mouse brain. It's a few petabytes. Leaving aside all practical, methodological, technological consideration. The theory very clearly says if you run the simulation on a digital cloud, it's all fake consciousness. It won't feel like anything. It's digital rapture for nerds, and you're raptured into nothingness.
Yeah, so it's not you.
No, it's nothing.
It's nothing. It's not even a thing. It's not even itself conscious.
Correct.
It wouldn't be a copy of you thinking I'm the real Christof Koch and that other guy down there is just the copy.
Correct. But, I'm sure people will do it because, we're desperate to cheat death in any which way. And so, the pharaohs built this gigantic pyramid. So, of course, a modern version of it, you're going to do the connectome. Yes.
Did you ever see that?
Both cases are illusory. I beg your pardon?
There was a documentary film made on Ray Kurzweil called was it the Eternal? No, not the Immortalist. It was the
Singularity.
Yeah, no, not the Singularity is near. This was on his personal life. In any case, it sort of follows him around. Of course, he has a whole basement in his home devoted to his father. His father died at age 51.
Yeah.
And so he's keeping as much information as he can that will be part of the reconstructed, essentially resurrection. Really, that's the right word, resurrection of his father. But of course, the father isn't there. It's just you're interacting with a copy of that's closer than a memory photo book, say, a photo album.
People want to reach immortality any which way, and this is the modern way of doing it. It's not that different from the pharaoh, having his slaves and all of his entire household killed and, put in his pyramid.
Yeah.
Ray Kurzweil does it in the basement. It's a little bit less glamorous than the pyramids of the pharaohs.
I can't remember. I think you were at that conference. The Singularity Summit was meeting in New York City.
Yes.
This was right at the time of the Occupy Wall Street. I forget what year that was, and maybe 2009 or so. And Ray Kurzweil, he gave his "I Have a Dream" speech, and kind of reminded me of being in church again. Like, we are the generation we're the chosen ones. We're the ones that are going to make it.
Rapture for nerds.
Yeah, rapture for nerds. Yeah.
Yes.
And then after he spoke, somebody else had a bunch of these little bots that were supposed to be all coordinated as like a hive mind on the stage, and they were going to run around and do something, but they couldn't get it to work because somebody had something on in the room that was interfering with the, with the system that they were using. And I thought, well, we're not even close to having these little robots working, much less.
These are some of the working issues with heaven, right? There's always going to be some issues with bandwidth in heaven.
Yeah, this is just opens up just crazy ideas. I mean, if you live forever, what would that even mean? In some other, the assumption everybody makes, I think, is that your consciousness continues, even if your physical body dies, either in a soul or a copy of your connectome on some other platform that continues. We still picture ourselves waking up in this other place after the death of our body. So it's sort of a natural born dualism, as Paul Bloom calls it. We just have this brain wired up to think that, there's something other than the material stuff. There is a mind as well as a brain. There's a soul as well as a body, and so on. And it's almost impossible to not imagine that, in the sense that if I say, imagine being dead, you can't do it, because to imagine something, you have to be alive. So in a way, all this has to do with the fact that we just can't imagine something. Just epistemologically, I don't know what it means to not be alive.
Well, it's interesting because people never think about where they were before they were born.
Right.
People are obsessed about what happens after death, but where were they before they were born?
They
never worry about that. Were they already in heaven before, and then they just got downloaded onto this particular planet?
That's right.
For, their life, and then they're going to go up again. And of course, it's terrifying, right? To most of us, it is terrifying. The idea of not existing anymore.
Is it? I was writing in one of my chapters. I dealt with this terror management theory. It's called.
Yeah.
Based on the idea that humans are the only species that know we're going to die, and therefore we're terrified by this, and this motivates us to be creative and build pyramids and write music and win Nobel Prizes or whatever. I think there's better explanations for why people do that have to do with sexual selection theory and trying to impress potential mates, but that's a different discussion. Again, this idea that people are terrorized by death, I don't think so. I think most of the time we're not walking around thinking, oh my God, I'm going to die. Maybe if you're 90 or something, or you have a terminal illness, but most of the time I doubt that you think about it.
Well, that's partly because we have very good suppression techniques, right? So it's an interesting question. When in evolution did we first have this insight we were going to die? We were one day not going to exist anymore. Is it Neanderthal? Did Neanderthal know this?
Right.
Is that the origin of religion? Right? Did people, when they first realized hominoids that they were going to die, is that one religion? I think some people are truly terrified. I know some of my acquaintances who are now constantly talking about death obsessively.
Really?
Yeah. Most of us, I agree. I'm not terrified by it. If I think deeply about it, it's scary. It's no question it's scary, right? If you really think about not being anymore forever and ever, ever, it's certainly scary. But most of the time, I don't think about it. Yeah, I don't believe in this terror management theory.
Yeah.
But people in general, particularly in this culture where we've removed death, we don't talk about death. Death is private. Death takes place in the confine of a hospital. It's not part of our public life anymore. Most people are certainly uncomfortable talking about it or thinking about it or being reminded of their own mortality. It's not polite.
Yeah, right. Yeah. So I looked into that in my chapter on, who's the first to realize this. Of course, we don't know these things don't fossilize, but there are those grave sites, Neanderthals and early Homo sapiens, with flowers, and the bodies are arranged in like a prenatal condition where they're sort of, buried almost like they're in the womb again, with some flowers and grave goods and so on. The assumption is that they're thinking, well, this guy's going to continue on in some other state, and we're sending him off with some goods, grave goods, that kind of thing. Of course, we don't know. I mean, it's like these, Werner Herzog made that beautiful film about cave art.
The dolphin, what is it called? The Cave of the Dolphin?
Yeah, no, what was that? Let me look that up. I mean, it's a phenomenal film, but basically we're looking at these images that are 30, 40,000 years old and thinking, well, if I did that, what would I be thinking that's just so projection, such a projection.
Yeah, but in terms of biology, we did. I mean, yes, there's still evolution going on today, but our basic cognitive apparatus was already fully developed 30,000 years ago.
Cave of Forgotten Dreams.
Yes.
Yeah, that's.
Yeah, with a. Yeah.
That's right. You can do that accent. I can't do that accent. Let's talk about altering your states of mind. This is becoming more acceptable now. Doing it, like microdosing hallucinogens. You did you write about doing the flotation tank with your daughter in Singapore. I guess you did this.
Yeah.
I did this, I don't know, back in the 70s when it was popular then. I haven't done it recently, but you strip down, you're in that, it's almost like the salt in the Dead Sea, and you float, and so I think I was in maybe an hour and a half, 2 hours, and after at some point I remember not really hallucinating, but I could almost see like my brain was just generating stimulation as if it were coming from the outside. And what did you experience?
Well, I of course had the opposite experience. I had this what Buddhists call a pure experience, right? So the question is, can you be conscious without being conscious of anything? Right, so usually we're always conscious of something, right? We're conscious of a nagging headache, or the worry that you have to deal with a tax return, or the sound of fury or pain or whatever. So the question is, can you be in the limit conscious, so not asleep, but without being conscious of anything? And so my experience was in the isolation tank, yes, you strip, you float in there. So very quickly you lose your bodily feeling, where the orientation, because you're suspended. It's totally dark, of course, you don't see, it's soundproof, you don't hear. Then early on you can still hear you can actually hear your heartbeat, right? And at some point you adapt to that. In my case then, I try to quiet my mind, of course, all the imagery of the residues of what I was thinking in my, that sort of comes up. You try to avoid thinking about that. And at some point, at least I felt I come to this perfect place where I'm like suspended in nowhere. I'm not conscious of anything, but I'm still somehow there. It's a limiting state, clearly. Because what would it mean to be conscious without being conscious of anything? And I found it very, very attractive. And of course, in the Tibetan Buddhist tradition, it's one of the things that they feel they want to attain. In fact, attaining this in a permanent state is sort of one form of as close as you can get to being enlightened.
Yeah, it takes them 30 years to get there. You did it in an afternoon. Maybe that's a quick way to do it.
It's obviously quick, and it takes this artificial aid, and I did it the second time, and it didn't work the second time. The second time, I was constantly thinking about being in the state, but I was too obsessed with it. Oh, I have to get into the state.
It's like trying to fall asleep by making yourself fall asleep by thinking about falling asleep.
Exactly.
Have you ever done any hallucinogens or anything like that?
Yeah, psilocybin.
You did?
And it's a wonderful experience, right? It's an absolutely wonderful experience. Seeing all these colors, and they're sort of more real than real, and feeling sort of this ego law. So it's a little bit like that. And of course, there's DMT. Right? The claim with DMT is that the spirit molecule dimethylethylene, that you can also go into this black hole state where you're conscious, but you lose consciousness of space, of time. You totally lose consciousness of ego, this ego dissolution. It's very powerful, but only short acting. So that may be another way to obtain this state of being conscious without being conscious of anything. And again, this theory says so. A brain that's minimal active will be conscious, but without being conscious of any one specific content. So it's not about function. Here I was in a tank. I was fully conscious, yet my brain wasn't computing anything. It wasn't planning. It wasn't speaking. It wasn't imagining. It was just in a state of being.
Is that like the global workspace theory, or?
No. Global workspace is very different. So global workspace, so that's the other competing theory that competes with integrated information theory in the market space of ideas, says that I'm conscious of a specific thing. Like now I'm conscious of this question you just asked me. So I have to keep that active, and I put that onto this blackboard. This is the metaphor they use, a black box architecture. It's going to be put in my workspace, and then it's broadcast to the rest of the brain. So now it's all about answering this question. And then it's broadcast to my speaking module, to my planning module, to my working memory module. And in the act of broadcasting, this is what gives rise to consciousness, sort of the act of broadcasting all this information to all the different parts of my brain. That's what the theory says. Ultimately, it's about this function of broadcasting, which is very different from integrated information theory, although some of its neural prediction may be similar.
But what I'm asking is taking a trip like that, does that give us some information that supports one theory of consciousness versus another, or is it really separate?
It speaks towards more integrated information theory, because global workspace, you have to have a content. So per definition, if there isn't any content to broadcast, you wouldn't be conscious.
Yeah. Would you do it again? Why haven't you done it again? You would. Oh, why don't you do it every day or every week or whatever?
Yeah, I know. No, it's a very good question. It's a very good question. Life is busy, and you have to. If you're too stressed, it doesn't work. It's an excellent question, Michael. Why don't I do this every day? I should, actually.
Well, so I mean, my listeners of this podcast are going to get sick of me telling the story, but after being on Joe Rogan's podcast with Graham Hancock, this is the alternative archaeology guy that writes about places like Göbekli Tepe, which is something like a spiritual center that's about 11, 12,000 years old, much older than any other monumental architecture. So it's a bit of an archaeological anomaly, I have to admit. But he, as a separate part of his career, he does a lot of ayahuasca, DMT, this thing. And he believes, as do apparently most people who do the ayahuasca trip, and they've invited me to come try this. I've never done anything like this, that they think it represents a place that you actually go to, that it's, opening the doors of perception, the arguments. Did you feel like this is a different reality that exists in some way, or this is just my brain on hallucinogens?
Well, look, I did.
Experientially, I mean.
Experientially, it's as real as anything else, right? But I know because, we study this in people, we can study it in animals. It has lawful relationship to the brain. I can partially induce it, using other physical methods. So I know it's something that the brain generates. It does feel real. It's no question. It wasn't like, oh, this is all fake. Like if you have, if you take psilocybin or LSD, that it doesn't feel, oh, this is fake. No, it's real because it's the only reality you have. It's a reality your brain generates. But then you learn it's very lawful. It has a lawful relationship with doses, with particular parts of the brain that are active. The same parts of the brain are going to be active in you and me, etc. So, it has all these lawful relationship. And so we realize it's part of your brain. Your brain generates it. It's not that you're physically traveling. It's just like I don't believe when I dream I'm back, on a climb that I'm actually transported to a mountain. No, I'm still lying in my bed. My brain is generating this dream.
But why would the molecular lock and key mechanism even exist in the first place? Why is it there?
Oh, because, why do most of us appreciate music, right? It's an evolutionary spandrel. Why are some of us very good at math? Was this really necessary for Cro-Magnon or Homo sapiens to survive over and to outdo, Neanderthal? No, it's an evolutionary spandrel that happens to be useful for certain things, or maybe not even useful, pleasurable. Like alcohol, I appreciate Pinot Noir. Do I believe that there's a specific evolutionary reason for me to like Pinot Noir? No, it's a side effect. It's something we discovered by experimenting with lots of different drugs, and we find there's this one that gives rise to pleasurable social interaction when you drink it.
Some of the near-death experience people argue that these naturally occurring chemicals in the brain are there for when you face death, when you are there at the edge of helping you transition from here to there. Wherever there is, it doesn't matter if there's nothing there after death, but that it reduces anxiety about dying. It quells the uncertainty of it because it's a real, warm, good experience that people have. This is one argument anyway. So it's an adaptationist argument.
Yeah, and I think that's true. I mean, Well, I shouldn't use miraculous in this context, but the wonderful thing about near-death experiences is that you can also have them if you're not religiously inclined. And yes, it massively reduces the anxiety that people have, facing death or near death. And we don't really understand the mechanisms, why that should be. If we could somehow understand them and then distill them into some therapeutics, then we can give that to people, when they get into those states and when they're very often agitated or very, very afraid or anxious.
Yeah.
So it's a very interesting phenomena that the dying brain, particularly the anoxic brain, the brain when it's cut off on oxygen, some subset, a small subset of people, 10%, 12% can experience.
Yeah. The experience is real. The question is, what does it represent? Something out there in the world or inside the head? I think
like any experience, you can't argue with the experience. The experience is as real as any other experience. Yeah. But again, it seems to have a lawful relationship to the underlying brain matter.
Yeah. So, what is your team working on in the future?
Well, so with respect to consciousness, we're trying to further push this project. What are the neural correlates of consciousness? In which part of the brain, in both brains of animals and in brains of patients and people. And then we now have this really interesting collaboration called an adversarial collaboration, where we get together with these people who have a very different attitude to consciousness, the people of the global workspace, where we agree upon a common set of experiments and where we agree ahead of time and get this manuscript pre-submitted. We're going to do this experiment. We're going to exactly specify ahead of time what this experiment is. If it comes out in this way, it'll support your theory. If it comes out in that way, it'll support our theory. It's called an adversarial collaboration. So it's really a new thing in the sociology of science, and we'll see how that works out.
Congress should do this.
Yes.
Well, I mean, it really, in a way, we want to solve the homelessness problem or the immigration problem or whatever.
Yes, it would be great. It would be great if that were to happen. Same thing with science. We're all trying to understand consciousness. We have very different takes to it. So let's agree on some experiment that could actually help distinguish, my theory from your theory.
Yeah. I have a little excerpt here from Steve Pinker's last book, Enlightenment Now, about his opinion on the hard problem of consciousness, and then just get your reaction to this. In the end, I still think that the hard problem is a meaningful conceptual problem, but agree with Dennett that it is not a meaningful scientific problem. No one will ever get a grant to study whether you are a zombie or whether the same Captain Kirk walks on the deck of the Enterprise and the surface of Zach Dorn. And I agree with several other philosophers that it may be futile to hope for a solution at all, precisely because it is a conceptual problem, or more accurately, a problem with our concepts. Then he discusses a little bit of Nagel's, what it's like to be a bad, and Colin McGinn's running away with that. He says, our best science tells us that consciousness consists of a global workspace. Well, you won't like this part, representing our current goals, memories, and surround. But even if that's wrong, he says, the last dollop in the theory that it subjectively feels like something to be such a circuitry may have to be stipulated as a fact about reality where explanation stops. In other words, we've hit an epistemological wall. Our friend Deepak Chopra, that's what he says. Consciousness is the ground of all being. It is the ontological primitive. There is no explanation for it because it just is.
Okay, so that may be right. There's no law in the universe that says everything will have a rational, reducible, empirical, testable explanation. Just like quantum mechanics. Why does quantum mechanics hold, right? We don't know, and people have thought about this, physicists. Why are we living in a universe where quantum mechanics seem to be the best explanation? Some people say it's just a brute fact. We just happen to live in one, end of discussion. Yeah. However, we do have to be careful. Our imagination is very powerful. What people said before can never be solved. Then suddenly 100 years later, it can be solved. Right? And of course, there is this. Now, you may have seen there are several books that have now come out about what's called panpsychism. Mm-hmm. Right, so panpsychism is this ancient belief, pan, everywhere, psyche, soul, that everything is in soul, that maybe Schrödinger, the guy after which the Schrödinger equation of quantum mechanics is named, he thought about this, that maybe at the root of physics, we have to include consciousness. So there's matter and space and time and energy, but there may also be consciousness. This is what IIT, what integrated information ultimately says. And so maybe we have to include consciousness in our very formulation of physicalism. So maybe under that notion, physicalism, the modern version of sort of materialism, has to be cast larger and has to include subjectivity. So I think that's a very promising development. So I'm very skeptical of pessimists who tell me, oh, you shall never know. Maybe yes, maybe no. I know for sure. If we don't try, we will not know.
That's my best argument for being cryonically frozen and coming back 500 years from now. And it's like, oh, consciousness, we figured that out 200 years ago. Yes. Here's the explanation. Oh, obviously.
Yes, maybe, hopefully.
Maybe, hopefully. I just had Donald Hoffman on my podcast. I think we released it last week. Yeah,
I saw that.
Yeah, so he's, he has this interface theory of perception. That like your laptop screen here with the little trash can down in the corner. If you open up my MacBook Pro, there's no trash can in there. These are just icons that represent some process, some algorithm that's grinding along here. And that's what he says about the reality of, this cup is, there's no cup in my brain. It's just a bunch of neurons. And this is just an icon that represents something else and so on. But he's taken that pretty far, not quite to solipsism, but that there is no possible way to know the true nature of reality.
Yeah, I mean, this is an old argument by Immanuel Kant, right? If you ever read Kant, one of the German idealists, he talks about das Ding an sich, the thing itself.
Yeah.
And we have these categories of space and time and causality. We'll never know what reality is really like. It goes back to our very beginning discussion. It's ultimately an inference process. So the most likely explanation is that there is something physical called this cup. Now, how do I really know? Well, ultimately, I don't know. It's an assumption. I'm going to go with that assumption, and it served us well, right? It served us well. Making these assumptions allows us to manipulate the universe, to build, nuclear reactors and cars and send rockets into space. So I think it's a reasonable assumption. Will we really know what it's ultimately like? No, we don't.
Yeah, but the fact that we can send a spacecraft to Mars and it actually gets there and sends information back is a pretty strong argument for there is a reality. Yeah,
yes.
and we can know something about it, even if not everything about it or perfectly represent it.
Yes, but yes. So, it's an old idea.
Yeah.
It is true. I'll never know, but I'm not really sure why. Yeah.
I mean, it's like this problem. I wrote an essay about why is there something rather than nothing. Even trying to get our minds around the idea of nothing is not that simple. I mean, no thing, it's a thing.
I mean, that's there. Maybe we've hit rock bottom. Will we ever be able to answer why there's anything other than nothing? I don't know. I
love this quote from Robert Kuhn. He co-authored a book.
Yes,
called,
I have.
Yeah. You know Lawrence because you've been on his show.
And I know his book about
the mystery of existence. Yeah.
Yes.
He wrote with John Leslie. So as he says, talk about nothing, not just emptiness, not just blankness. And not just emptiness and blankness forever, but not even the existence of emptiness and not even the meaning of blankness and no forever. I mean, at some point, we've just hit rock bottom. There's the words just fall off the page and I have no idea what you're talking about.
Yes, I think this is very likely one of those cases.
I don't know how much you've read about the Mysterian mysteries. It could be our brains are just not big enough to have the concepts to answer those kinds of questions. They're just big enough to think of the concept and the problem, but not answer it.
At least our current version, yes.
Yeah. Or, Wittgenstein, the words we use, we don't have the right words to have the concepts to even think properly about it.
Things like that. Yeah. So I'm just talking about a little bit easier things like consciousness.
Yes. That's right. You have the easy problem. The easy problem of consciousness. Well, the neural correlates, I guess, are the supposed easy, but they're not that easy. All right. So the feeling of life itself, this was a sequel to your, romantic reductionist. What are you? What's next on the Christof agenda for big questions?
I don't know. I mean, I'm running this large institute with 300 plus scientists. We're very productive, so I might take a break from writing. Although, right now I have several Scientific American articles coming out on brain death. Is brain death irreversible? There's some really interesting, science going on there. So stay tuned. There are always interesting things happening in the world of neuroscience, and unlike cardiology, let's say, you are your brain. And so there are all these fascinating ideas tied up with your brain and your identity, and where do you go at night and where do you go after death, and what can we do to preserve the brain, etc.
What's the future of the Institute now that Paul Allen's gone?
So we are on a secure, this was, we talked about with Paul about this many times. There's a estate. His sister, Jody Allen, is in charge of the estate, and we are now planning for 25 years. We currently are moving on a 25 years trajectory that was discussed at great length with Paul Allen. So we are here to stay.
So you're there for the duration. You're not going back to Caltech or being a professor or anything like that.
I don't know. I'm not going back to Caltech. Well, my presidency, was for 10 years. So I'm gonna step down from that in 2 years or something like that, and to return to a more active role as scientist. I'm a scientist. I love science, and so I may go back, but remain here at the institute and just do science and writing full time again.
Oh, because you're mostly doing administrative work now.
A lot of it is there are 300 people. You have to make decisions, what to fund, what not to fund. And,
you have 300 employees. I have 6 employees, and that's 5 too many. I don't know how you have 300.
Yes, sometimes it's challenging.
And are you still mountain climbing?
No, I now here, because it's much more conducive. So I don't have a car. I just bike every day in a row. Crew rowing. It's also much more appropriate to the metaphor of being a team. Because, in a boat with 8 and a coxswain, you're only as good as your weakest link. And, no matter whether people are big or small or have a big frame or a small frame, you have to synchronize. You have to be a team. It's not the star performer. It's really the team and it's set as a whole that counts. And so it is with our institute here.
You're like a single neuron with all these other neurons that are somehow coming together as a single brain.
Yeah, so we're a team. So what makes us very different from, for example, university, we try to only take on 1 or 2 other things as a team and to discuss. So that has some unique challenges as any other large, astronomy or elementary particle physics project has.
Yeah, and do you guys work at all on brain diseases like Alzheimer's and senility and dementia?
We're starting to think about that. So most of what we do is still basic science, right? Trying to get the basic layout, particularly of the human brain. But as that's become very successful, we're now moving into developing viral technology for the human brain. So in other words, once we know there's some specific defect of a specific gene that's missing in a particular type of cell, can we then devise technologies like viral technologies to deliver that missing gene to those right neurons in order to cure people? Yeah, so we're starting to think about disease applications.
Yeah, you guys got to solve this problem before you and I hit the wall, because,
Yeah, I know.
These people, like when I was writing my book, it's like, Shermer, don't you want to live to be 500? I'm like, look, just get me to 90 without prostate cancer and 100 without Alzheimer's and dementia. And, these are hard problems. And,
yes, they are.
Through our mutual friend Deepak, I met, Rudy Tanzi from Harvard. He's, like the big Alzheimer's guy. And it's like, when you really bore down on it, we're kind of clueless about the causes and, the plaques and tangles. Yeah, but what causes the plaques and tangles? Yep. No one knows. Is, genetics, environment, he has, general stuff. You should eat well and exercise and sleep. Yes. I know. I'm doing that. But what else? And, should I do Sudoku puzzles? There's not much.
I think you're fine. I think you'll be fine. Just be very active. Yeah, I mean, but the brain is by far the most complex system. It's vastly more complicated than any system physicists have tackled with. Mm-hmm. And it might well be a while before, we fully understand these diseases and can cure them.
Yeah.
We just have to keep trying. All right, Michael.
Yeah, I know it's pressing on your time now. The book is The Feeling of Life Itself. We will release this on the day it comes out in September, whatever that date is. And congratulations on another good book.
Thank you much. That was a great conversation. You asked fantastic question. You obviously have deep background.
I'm kind of a dummy. I just ask good questions because I don't really know. I'm just curious.
You know a lot. You know a lot.
I will see you next time I'm in Seattle or next time you're
All right, in
down this way.
Pasadena.
Yep.
Take
All
care.
right. Bye-bye. Bye-bye.
Bye-bye.